everybody should be able to tell me this. What do we do? On A, so what do I have to write out first?
3x plus 1 negative 2x plus 5.
Okay, so we do two options. One of them stays the same. The other one, we have to do the opposite, which changes both of those signs. Okay, with absolute values, we're always doing two separate things. So on the first one, if you want to solve, you can subtract your 2x, subtract our 1, so we get x equals negative 6. This one, if I add my 2x, subtract my 1, get 5x equals 4. So if we divide by 5, we get 4/5. Now, I did this problem intentionally because there's one on the homework kind of like this. We got our two answers. If you check this, if you put in a negative 6, we get negative 18 plus 1 is negative 17. Over here, we get negative 12 minus 5 is negative 17. Does the absolute value of negative 17 equal negative 17? No. The reason this happened is because I had an x outside my absolute value, and sometimes that can give you answers that don't work. So the negative 6 doesn't actually check. We talked yesterday about how we can always check them by plugging them back into the originals. If we check 4/5, okay, if I put that in, I get the absolute value of 12/5 plus 1, so the absolute value of 17/5 equals 8/5 minus 5, so negative 17/5. Does that work? So I got two answers, but did either one work here? No. So what's my actual answer? No solution. Again, the only time that's going to happen is when you have a variable on the outside. On your homework, if you pull that handout out, you might want to look at number 10. You got two answers on that one. You should have gotten a negative 38 and a negative 4. But when you check them, can you plug a negative 38 back in? Because when you do 5 times negative 38 plus 37, you're getting a negative outside that absolute value. So on number 10, you need to check. Only one of your two answers works. Okay, so you need to fix that. That would be a good time. On B. Okay, this is a less than. Is that an and or an or? And. Okay, there's two different ways of doing it. The way I have always done it is just to make one big inequality, because then you know at the end how to write your answer. I think when Mrs. Keller taught it, she had to go ahead and write two separate ones, but you had to graph it at the end to know what your answer was. So either one is okay. You can do it like I talked about yesterday. If it's an and, you do the two separate, or the one big one. If you do the two separate, you set it up like an or. So you do the first one, it's an and the second one, when you do the negative, you always flip your inequality, just like if you multiply by a negative, it flips the inequality. If you solve this, x is less than or equal to 2/5. Okay, this one, you get x is greater than or equal to negative 6/5. It's an and, so what's my final answer supposed to look like? Am I going to have one piece or two? One. If you think about your graph, if you do it this way, you're probably going to need to draw a graph at the end. Less than or equal to 2/5. Be starting at 2/5. And going to the left. Greater than or equal to negative 6/5 would start here and go to the right. Because it's an and, you can only take the overlap, what got shaded by both of them, and it's in between those two numbers. So your actual answer is the interval, -6/5 to +2/5. They get brackets, why? The equal to gives me a bracket. If you have an and, your answer should look like this every time. It's going to be in between the two numbers. That's maybe the benefit of setting up the one big inequality. When you get to the end, you get -6/5 is less than or equal to x is less than or equal to 2/5, so it tells you it's in between those two. If you do the two separate ones, just think about your graph at the end. All right, C, is this an and or an or? Or. So, two separate pieces, greater than 11, or you flip it and make it a negative. So x is greater than 5, or x is less than -17. If you think about your graph, okay, greater than 5, parentheses because it's not equal to, going to the right, less than -17, so not equal to, so parentheses, going to the left, or says you take anything that gets shaded. So ors should have two separate pieces at the end. You have to give me the interval. So this one's starting at -infinity, going to -17, or this one can start at 5 and go to +infinity. So on your homework, you should have done, if the problem had an inequality, I expect an interval at the end. If it's an and, you should get one thing. If it's an or, it's two separate ones. Any questions there? I'm not going to collect the homework quite yet. We're going to flip things around today. I want to do some notes first. We already have our notebooks out, so we're going to start there. So yesterday we talked about absolute value. I did a little bit of that today. I'll probably do a little more tomorrow. Then we have our long weekend. Monday we come back and we're going to review all the stuff that we're doing this week. So we're going to hit absolute values again, as well as this next piece. We're talking about piecewise functions. So we'll spend today and tomorrow talking about the absolute values and the piecewise as well. When I talk about a piecewise function, there are lots of different ways it can look. In general, piecewise means that you have different rules for different parts of the domain. So a piecewise function is defined differently in different parts of the domain. So we have multiple rules for that. We are going to focus today on graphing and evaluating these. To graph, we are going to make a T-chart for each piece. And when we do that, we need to always plug in the endpoints. So we're going to start just by graphing a couple piecewise functions. The first few we're going to look at have two pieces, but technically you could have as many as you wanted. Piecewise just telling us we have more than one rule. So we can have 2, 3, 4, any of those. So our first function, f of x equals 2x plus 4 if x is less than 1, and 4 minus x if x is greater than or equal to 1. When we graph this, we are going to do a t-chart. We have two pieces, so we are going to need two t-charts in order to graph it. For my first one, you have to plug in the correct x values. It says x is less than 1. But can you tell me the first number less than 1? 0 is the whole number, but is 0.9 less than 1? Is 0.99 less than 1? 0.999, 0.99999. So it's not like we can plug in the smallest. So what we do is we still plug in that 1. But since it wasn't equal to, what will I have to put on my graph? Yep. So I'm going to make myself a note. At 1, it will be an open circle. Okay, so now to get my y, I'm just going to plug it into this equation. So 2x plus 4. So 2 times 1 plus 4 is 6. My other x values need to be less than 1. So maybe a 0 and a negative 1. If I put in a 0, 2 times 0 is 0, plus 4 is 4. If we put in negative 1, negative 2 plus 4 is 2. So if I want to graph this, I have to start at 1, 6, and that is an open circle. But that's the only open circle. Then we have the point 0, 4, and that's closed. Negative 1, 2. When I draw this, does it go forever in both directions? No, it was only true that x was less than 1. So it's only extending in the less than direction. So we need at least 3 points to get a good idea of our graph, but we keep going only in one direction. Now we do the same thing for the other piece. So I'm going to make a new t-chart. What is the first number I'm going to plug in? 1. Will that one be open or closed? Closed because it has an equal to. And then I need things greater than 1. So maybe a 2 and a 3. So I plug those into the 4 minus x. So 4 minus 1 is 3. 4 minus 2 is 2. 4 minus 3 is 1. So 1, 3, it's closed. 2, 2, 3, 1. Does this go both ways? No. It started at 1 and it was only true for things greater than 1. So we are only extending to the right where the x's are bigger than 1. When you get to the end, we need to kind of check. This is a function, so it should pass the vertical line test. If you've made a mistake, you'll catch it there. If you accidentally extended this line the other way, does that pass the vertical line test? No, so I know I made a mistake. If I accidentally did both of these closed circles, does that pass the vertical line test? No, so I know I made a mistake. So double check it at the end. It was originally f of x equals. That means it's a function. The x's don't repeat. Can we do the domain and range of this? Domain, what x's do we hit? The red one stopped at 1, but the blue one picked up there and kept going. My range, They're both coming from the bottom, so it's coming from negative infinity. The blue one stops here, the red one goes up to 6. So my highest point is 6, but it was an open circle, so that would be a parenthesis. So we should be able to do domains and ranges from any of these graphs. Let's graph another one. So again, 2 pieces. So we're going to do 2 T-charts to start. So if I do my first one, what is the first x value we have to plug in? 0. It has an equal to, so it will be a closed circle. And then I need things less than 0, so numbers smaller than 0. I'm plugging them into this function. So the opposite of x, opposite of 0 is still 0, minus 2 is negative 2. Opposite of negative 1 is positive 1, minus 2. Opposite of negative 2 is positive 2, minus 2. So 0, negative 2 was close. Negative 1, negative 1, negative 2, 0. Again, this started when x was 0. We're extending it for x is less than 0. So this is my starting point. It keeps going this way only. All right. If I look at this one, what number do I have to plug in first?
0.
And then we need things larger than 0. Okay. Would 0 be open or closed? Open, because there's no equal to. Does everyone know how I decide if it's open or closed? And does everyone understand how I know what x's I'm plugging in? We start at this point, so we start with 0, and this says x is greater than, so then you just plug numbers bigger than 0. Any questions? So if I put in 0, 1/2 times 0 is 0, minus 2. If I put in a 1, 1/2 times 1 is 1/2, minus 2, 1.5. If I put in 2, 1/2 times 2 is 1, minus 2 is negative 1. Now, could you put in, if you didn't want fractions, could you have plugged in like 0, 2, and 4? Yeah, you have to have the 0 because that's the starting point, but then you could put in any numbers larger than 0. What happens if you end up with, at 0, negative 2, we already have a closed circle. If you have an open and a closed circle at the same spot, what do? We just leave it closed. Okay, don't try to like draw an open circle around it. If one piece fills it in, it's a closed circle. Then we have 1, negative 1.5, 2, negative 1. So it started here. Should have been open, but the first piece had already filled that in, so we just leave it closed. And it should look like that. Questions there? Let's try some more. Okay, my next function. F of x equals x minus 1 if, sorry, negative x plus 1 if negative 3 is less than or equal to x is less than 1. 2 if x equals 1 and x squared if x is greater than 1. So this one has 3 pieces. How many T-charts am I going to need? 3. We do 1 for each piece. Okay, I did ask a few more questions on this one than just the graph. The first question, I want to know f of 0. It's a function, so you can only get one answer if you plug in 0. How do I know which of these three pieces I plug it into? I can't plug it into all three, that would give me 3 answers. Is 0 the x or the y? We're finding the y. The number you put in is the x. Think about function notation. If my x is 0, we have to look here.
Well, if you graphed them and looked at which
You can
one
look at
crossed
your-
the-
So if you graphed it and looked at the graph, that would work. If you're just looking at the equations, is 0 greater than 1, equal to 1, or between -3 and 1? Between -3 and 1. So you would only have to plug it into the first piece. So you could certainly do this after the graph. But in a second, I'm going to give us some without, and we're going to solve them without graphing. So if I just put it in the first one, the opposite of 0 is still 0, plus 1 is 1. When I say f of 1, which piece are you going to plug that into? When x equals 1. So what do we get out? 2. If I said f of 2, which rule would we use for 2? 2 is greater than 1, so you plug it in here, so 2 squared is 4. So you can evaluate piecewise functions without drawing the entire graph. You just have to pay attention to which part of it you're plugging into. It's a function, you can only get one answer in, so you can't put it into every piece. So you have to find the appropriate one. Let's go ahead and graph it, and then we'll answer the rest of the questions from the graph. So we already said we would need 3 pieces. So the first one. How many endpoints did I give you? 2. So we have to put in both of those. I have to put in the -3. I have to put in the 1. And then you can do something in between them. So maybe a -1. -3 had an equal to, so that's closed. But 1 did not. So 1 is going to be open. So if I plug those in, opposite of -3 is +3. Plus 1 is 4. Opposite of -1 is +1. Plus 1 is 2. Opposite of 1 is -1, plus 1 is 0. So we have -3, 4 is a closed circle. -1, 2, 1, 0 is open. Now this had 2 endpoints, so does it keep going in either direction? No. It goes from here to here, only between -3 and 1. Next piece. 2 if x equals 1. There is only a single x value we can put in, only 1. And we get out 2. So 1, 2 is just a dot on our graph. That piece is just giving us a single point.
If it's an equal to like that, it's always closed.
Mm-hmm.
I guess how could it be open?
Yeah, if it was a not equal to, it would be an open circle, but yeah, I wouldn't be able to give you a piece just like that. Okay.
If it's open, it would mean that it's not.
Not equal to. The last piece is for x greater than 1. So we have to plug in 1, but it wasn't equal to, so that's open. Then we need things larger than 1, so maybe a 2 and a 3. And my function is x squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9. So I'm getting part of a parabola here. So 1, 1 is open. 2, 4, 3, 9. And that one keeps going, because it was for everything greater than 1. There was only one endpoint, so the other direction keeps extending. Alright, do a quick check. Does mine pass the vertical line test? Yeah. You know, right here, probably the only thing in question, but I have one closed circle and two open circles. So it passes the vertical line test. I have a function, I'm okay. If I did my domain, this graph starts when x is -3, it was a closed circle, so equal to. The blue one stops at 1, but I have a red dot. Then my green one keeps going forever, so it'd be -3 to infinity. Range, what y values do we hit? 0 would get a parenthesis, because it was open. Okay, and the green one keeps going up forever, so 0 to infinity. The other question I asked, is this continuous? Last week we talked about being continuous, or maybe it's even before that. Continuous, can you draw this whole thing without picking up your pencil? No, we have to pick up our pencil to jump from the pieces, so this is not continuous. All right. I want to look at this question. So without graphing, I want to see if we can evaluate each of these things. So if I said f of 0, this is an x value. So I have to look at my x rules to decide which one I'm using. Is 0 greater than -2, equal to -2, or less than -2? Greater. So I'm using the first rule. So that's 2 times x minus 1. And we get -1. If I said f of -2.1, is -2.1 greater than -2, equal to -2, or less than -2? Less than. So we use the third rule. So 6 minus 3 times x, which is -2.1. F of -2. Is -2 greater than -2, equal to -2, or less than -2? Equal. So we use the middle piece, which is x squared. -2 squared is 4. If I say f of 3, is 3 greater than -2, equal to -2, or less than -2? Greater. So we're doing the first piece again. Are there questions on that? So, let's kind of talk about the rest of the week. You guys still have that section 2.4 handout? And it is going to be due tomorrow. So I'm letting you hang on to it for another day. That means if you didn't do well, or if you need to check it, or if you have questions, you've got a little extra time to get that done. So if you want to check it, you have time. If you need help, come see me in advisory. I am giving you another handout today. It is going to be due on Monday. However, there will be one more handout tomorrow. So today and tomorrow, we're working on the same section. But I haven't done as many of these graphs as I would like to. So I want you, don't just not start it, because then you're going to have double the homework tomorrow. Okay, but I'm not going to collect that until Monday, along with the second 2.5 handout.